Hello and welcome to the third dimension. In this video we're going to discuss how to digitize on your point cloud. This is probably the best feature of the point cloud viewer. It will allow you to create a professional quality site plan entirely from data extracted from the point cloud viewer. The distance measurement tool creates 3D polylines, and the point measurement tool creates a 3D circle that we can export into any CAD software that can use a DXF. We'll start off by creating 3D polylines on linear features and breaklines, such as top and bottom of banks. I like to quickly set my polylines and then go back and fine-tune their grips after. When you're in the distance command, you can't left or right click and hold to move your view. However, you can still zoom in or out. If you need to adjust your view in the middle of digitizing a feature, end the command, reposition yourself, and zoom in and click the same point as the one you left off on. To digitize wall buildings, instead of trying to pick the corner, I like to define the face of a wall by picking 2 points on the surface close to the ends, and later when I bring the line work into CAD, I'll intersect those lines with the other walls that I made in the same way. The reason I do this is because photogrammetry especially has a difficult time defining sharp corners and tends to round them off. Using this method will reduce the error created from this. Similarly, for features that have a horizontal face we want to define, such as the top of a paver retaining wall for example, I will digitize my line in the middle of the pavers where the elevation will be most accurate, and later use the orthophoto to horizontally reposition the line in CAD. This is getting an accurate elevation from the point cloud and an accurate horizontal position from the orthophoto. Of course, this won't work for features under eaves and tree canopies. These situations are where it's handy to be able to digitize directly on the point cloud. To define point features, such as trees or power poles, or elevations, such as roof peaks or eave elevations, I'll use the point measurement tool. Once we have our line work digitized, we click the DXF button under the export header in the scene menu. This will download a DXF to your downloads folder on your computer that you can rename and relocate as needed. For larger projects, I generally make a different DXF for different features. I'll have one for buildings only, I'll have one for tops of banks, I'll have one for bottoms of banks, etc. Open your DXFs with your CAD of choice. I will be using Civil 3D for this example. Copy and paste to original coordinates in your drawing. Set your coordinate system, bring in the imagery if you have it, layer your line work. An orthophoto will tend to be a bit more accurate horizontally, so I may go back and tweak the grips a bit here and there horizontally. I should mention this rule doesn't hold up for features such as power poles or trees that are significantly above the ground surrounding them. To define point features, import the DXF that's full of 3D circles that were created with the point measurement tool, and simply pick points using a center snap and define the description for each as needed. I previously touched on how to digitize line work for buildings. To draft the line work, flatten it into a 2D polyline on a common elevation and fill it abutting line work to create intersecting corners. You can then assign a constant elevation for your building or slab if desired. Spend some time going through your drawing, cleaning up line work, and going back to the point cloud to grab any data that you missed. If you want to increase data density of your 3D polylines by adding additional nodes, but want to interpolate the elevation between neighboring nodes, you should convert your polyline into a feature line. Then you can insert an elevation point if you strictly want an additional elevation node online, but I recommend inserting a PI. This will interpolate a new elevation, holding the grade from the 2 points on either side, and allow you to set it horizontally where you desire. When you're done, you can explode it and return it into a 3D polyline. To draft around a curved object, you can turn your 3D polyline into a spline. This will give your curved line work a more visibly appealing look. To offset that 3D polyline, use the stepped offset command. This will allow you to quickly draft the side and tops and bottoms of a retaining wall or other features with a constant width. To draft roof peaks, I use the orthophoto to define them horizontally using the PL command. Then I assign an elevation from the points I created earlier on the peaks and eaves. To create multiple spot elevations quickly, accurately, and efficiently, I digitize LINEWORK and pick a point everywhere I'd like to define a spot elevation. I'll make separate DXFs for spot elevations on bare earth and others with vegetation. The LINEWORK with vegetation, I can manually lower a set amount to compensate for it. I've found about 5 centimeters is a decent approximation for most lawns, and that's what I'm going to use today. To manually create a vertex at each point, use the Create Point tools and set your default labeling and elevations to automatic and create points by polyline vertices. Then every line you select, a new COGO point will be created at each vertex. You can delete the line work when you're done. Once you have all your line work and spot elevations in place, you're ready to create a surface. Make a surface and set your break lines and point groups. After a bit of cleaning up some triangles, you're just about done. If you think there are any gaps in your data, it's not hard to go back, draw a few more lines on the point cloud, bring that DXF in, and add it in. This is the same site with a surface created directly from a point cloud after some manual cleaning of points. As you can see, there's a lot more data density, but also a lot more noise. The benefit of creating a surface from digitizing the way I've demonstrated here is it's efficient and accurate. You can choose every point you're picking to ensure you're getting the actual ground and not spending days manually going through a point cloud and deleting every bad point, every feature that isn't the ground, and every bit of vegetation. This is not to say there is no situation where it wouldn't be more efficient to use the entire point cloud. A wide open bare earth construction site free of snow, vegetation, and clutter, for example. But since this isn't usually the case, this is an alternative method. Add some hatching, a few point styles and annotations, and we have a professional quality site plan created 100% from UAV data. We can't forget the most important part when using UAV data: quality control. Without it, we're just taking an educated guess on how things actually fit. We have our processing report, but to strictly rely on that can be very dangerous without extra QC observations. It is for this reason I always recommend sourcing your point cloud data from a surveyor that has the experience and tools to perform the proper QC checks, and a professional surveyor is the only person that can define your property boundaries. Here I'm bringing in some RTK observations I took on the same day of the flight. These observations are entirely separate of the surface and the line work I've created so far. You can see my edge of concrete shot is about 20 millimeters off horizontally and 47 millimeters off vertically. I'm seeing the same from this shot here. This caused some concern for me, so I went back and checked my point cloud. Then I remembered the slab has some significant sag in the center where I pulled my elevation from. After adjusting the edge of the concrete line work with the elevation I pulled from the edge, I had a result that agreed to within 20 millimeters vertically as well, about the accuracy we can expect from RTK. As I go through and do my checks, I generally find hard surface checks align to within 2 to 3 centimeters on average. You'll see that my bottom of wall shot didn't agree to within 8 centimeters vertically, and that has to do with the issue I brought up earlier about photogrammetry rounding sharp edges. What I should have done was digitize the bottom of wall a bit further out on the road and get an accurate elevation, and adjust it horizontally in CAD after using the orthophoto. The grass spot elevations fit to within 1 centimeter on average. This was because I was able to drop the line work that I used to create them down by 5 centimeters to compensate for the vegetation. When I checked my surface in areas that I knew were going to be an issue because they had varying vegetation that couldn't accurately be adjusted with a uniform drop, I saw variations of 13 and 19 centimeters. This site plan is for a shed that is nowhere near this area, so it won't be a problem. However, if there was vegetation anywhere near my area of interest, After I flew the site, I would have used my RTK rover to take some shots in that area and used them instead of the points picked from the cloud in that area. Fortunately, surface creation from this method of digitizing on the cloud lends itself very well to mixing data in with traditional surveying. And that wraps up the demonstration how you can turn your point cloud into a site plan that, combined with property boundary line work, you can use as needed.